Hello friends, this is Shubham Maurya and welcome to the Embedded and Robotics Programming for Beginner. And in this tutorial series, we are going to talk about what is an embedded and how to codes for the embedded programming and how to simulate the circuits of the embedded programs. So, in order to start the embedded programming, we need some softwares, some basic softwares. Like if you are a beginner, then CV-AVR is a much better software for you, where you can code for your embedded programs. And in order to simulate the circuits, you need to have the Proteus simulator, where you can simulate all the circuits which you code in a embedded programming. So, let's talk about the what is an embedded system. In a simple meaning, you can say that embedded system is just like to create anything automated. Okay, then the question rises that how to create something automated, uh, how to control all those things automatically. So in order to control those things, we need to have a microprocessor where we can code, microprocessor or microcontroller where we can code about of the embedded. So let's talk about the microprocessor which we are going to use in starting. So in starting, we have to need the microprocessor Atmega. It has various form like Atmega 16, Atmega 8, Atmega 32. We are going to work on the Atmega 16 or Atmega 32. So uh, have a look on the Atmega 16 or 32. Both look same. It just there is only a difference of memory and bits. So as you can see that it has a 40 pins IC, and it have a 40 pin IC, and you can see that it have four ports: port A, port B, and port B, port C, and port D. So there are four ports. Each ports have a eight pins, and there is an specification of the each ports. Like port A have an ADC port pins where we can convert the analog data into digital log, and port B have several kinds of extra pins like interrupt, timer pins, and uh, for the communication pins. And port D have a lot of uh, useful pins like RX, TX, interrupt to interrupt pin, and the three PWM pins. So we will talk about all those things in the upcoming lectures. But uh, now we have just an idea about an microcontroller. So microcontroller is a device where we can control the all the circuits, all the circuits and all the instrument throughout the microcontroller by using a simple program. So all those the specification of the all those pins, that all those pins are the IO pins. Okay, IO pins means we can create it input pin or output pin accordingly as we need to use So let's start some basic programming and how to approach in all those circuits and programming, how to connect the circuit with the programming. So first of all, we need to open the Proteus simulator. So it take some minutes. So that's the overview of our Proteus simulator. And if we need to bring some items, so this is a part where we can pick the items. Click here. Now what we need? We need Atmega. Now Atmega. There are a lot of Atmega, and we will select our Atmega 16. Yeah, that's okay. Yeah. Now I am selected the Atmega 16. So now I want some LEDs. LED. Then I can get my LED, blue LED. Okay. So let's draw some basic circuits. This is an Atmega. I think it looks something small. Okay. Now it's adjusted. So This is an Atmega. We have an A port, B port, and C port and D port. And now we will connect the LED there. Like we took the LED and its one part is connected through the microprocessor, and next part will connect it through the ground. Then in order to get the ground, I will get the ground from there. So just connect it directly. So now we are going to write a program where a simple blinking LED for the blinking of LED. So that was our circuit, and what we are going to do, we are just a code which we are going to do in a CV-AVR code version AVR. You can download it from the any sites, or its official sites are also there, and you can download it from there. So let's just, in order to start the project, just click on the file menu, then new, then project. Okay, do you? Yes, I want to create a project. Okay, it takes some time just because to open all the libraries of the Atmega 90 at 1980 tiny Atmega and all those things there, so that it takes some time, not more than 30 seconds. So uh, here are the parts where we can set all those things. Now this is our basic tutorial where we are going to just only for input and output, so there is no need of all those things. So just write on program, generate, save and exit, and select the place where you wanna save your code. I selected there, then I first, this is my first project, first and first. You have to save the same file, you have to save the file the same name 3 times. Then there are some regenerated program where the registers are on automatically, and if you want to remove all those registers, you can remove. If you know the programming of registers, then just remove and write it yourself. Like if you are going to code in a AVI studio, then there is no any kind of registers, then where you have to write the registers by yourself. But if you are a beginner, then I think CV-AVR is a much better for you. So let's start for your coding. Then we are going to write after the all those registers, so that our code starts according to ourselves. So there are in a there are 4 ports, A port, B port, C port and D port, and we are going to work on the A port. So right now our port is an working like as output port. So how to define in our code that this port is an output port? So in order to define the port that this is an output port, we are going to use the command ddrx. It defines the which port you are going to define at the place of x. So if I wanna define the port A, then I will write ddra is equal to, we are going to write in a binary form, so that 0b, which defines that we are going to write in a binary form. So if you want the seventh pin as a output, then just write it 1, and if you want the seventh pin as a input, then just write it 0. Then accordingly we will write all those pins, like seventh pin as output, sixth pin as output, fifth pin as output, fourth pin as a output, third pin as a output, second pin as a output, first pin as a output, and zeroth pin as a output. So here we have defined all the pins as output: first pin, second pin, third pin, fourth. So it's fine. So here we have defined all the pins as a output. If you wanna define any of the pin as an input, like I wanna define the seventh pin as an input, then I will write at the first place 0. So right now we have defined the ports, that either it is input port or output port. Even we can say the pin. If you wanna define an individual pin, that I want to define the first pin as an output, then I will write ddra dot the pin number 0th is equal to 1 or 0. If you wanna define it as an output, then just write it 1. If you wanna define it as an input, then just write it 0. Then here I will write the 1. So because I have connected an LED at the pin number 0, so there is no need to define all the other pins. So here we have write the pin, uh, we have defined the pin as the output. So now we are going to give the state. In order to give the in order to give the state on the pin, if you have defined as output, then you will give the state that either it is high state or low state. And if you have defined the pin as the input, then you will scan the state that either it is this pin is on high state or low state. So here we have defined the pin as an output pin. So we will give the an output state that either it is on high state or low state. So in order to define the output, we are going to write port. So which here we are going to use a port. So port A and the pin number 0.0 is equal to, if you write 1, then it will be on higher state. If you write 0, then it will be on lower state. Then here I'm going to write 1, then fine, and just go and compile it, build all. Okay, then there is no error and no warning. Okay, fine. Then now I'm going to dump this code in my Atmega. Just come in the middle of this one, click twice. Here is an program file. Now we are going to select the program file. We will get the program file where we have saved. Okay, first now I have select my program file, and there is a button where we can play my circuit. Just press it. Okay, fine. Now it is on high state now, so that LED starts glow, you can see there. So let's do something exciting, as I used to do. So I remove this part. I'm going to write the code in that while one. In the while one, the loops running and running and running for the infinite time, so that my code is running and running for infinite time. So let's give an state like port, sorry, port A dot 0 is equal to 1. So that pin gets on a high state, and I want to then if I write this port A dot 0 equal to 0. So this pin gonna on high state, then again on low state, then again on high state, then again on low state, so that LED gets starts blinking. But there is a problem. The microprocessor works very fastly, so that both commands running simultaneously, and it doesn't show any effectively results. So that I want to give an delay programs. So the syntax of the delay code is this. Sorry, it is on small letter. Delay underscore ms. The we can give the delay time in the seconds, in the milliseconds. I'm going to delay of 100 milliseconds. So here we have write the delay code, so that we have to define the delay library. So here we are going to use the define the delay library, like there is Atmega 16.h, and we will add that. So now just build all. Okay, fine, no error and no warning. So just play it again. Now you can see that LED glow for the 100 millisecond, but it doesn't seems that it is on 100 milliseconds. Yes, because there is an problem. First stop the circuit and just come and click in the middle of this one. Here we can see that fuse clock frequency of the fuse, it's set on the 1 megahertz, but where we are going to code, we set the 8 megahertz. So we have set the same clock frequency 8 megahertz, and click on OK. Now you can see the properly that it's glow for the 100 millisecond and it's off for the 100 milliseconds. So guys, this is an basic tutorial for the embedded programming, where we have learned about that what is an CV-AVR, what is microprocessor, and and how to simulate the circuit. So just wait for the next episode where we are going to learn more exciting about the embedded programming and robotics. Thank you.